Cool. So what I want to do with this panel is, because there was so many, and Sunny, just join when you can, I'll bring you on. There were so many questions that didn't quite get asked. We kind of pushed through this. So I kind of wanted to start this off with like a few questions to each of you about the projects. I want to start with you, Chris, because the Enoma part, I couldn't hear exactly how it's working with IBC or pools. Like I kind of got that it was this, moving the funds around and there's a private way, but I was hoping you could just give a little bit of a connection point there. Maybe take a second to do that.
Yeah, absolutely. So in sort of the basic case, Enoma functions as a blockchain running on Tendermint. We're working in Rust for the SDK with a multi-asset shielded pool. So an instantiation of our extended version of ECC sapling circuit, which supports fully shielded transfers using standard like notes and commitments, adjusted to also shield the asset denomination. So this means that there's a logical shielded pool on Enoma, which all assets can elect to share, including fungible and non-fungible tokens, anything that can be like represented as a combination of its denomination string.
Do you picture there being kind of like an LP token type thing happening on each of these chains, or like how is the liquidity provided? Or is that too early?
That's possible. I mean, I'm not sure. So there are tricky, the research area, which I guess I'm most interested in, or which to me remains most open, is in balancing the security isolation or fault isolation provided by IBC with the desire to have cross-chain privacy. So the technical implementation of cross-chain shielded transfers is not that difficult. But the tricky thing is that it changes what kind of fault isolation you can get, because IBC provides fault isolation to prevent some other malicious chain from inflating your token by tracking what the incoming and outgoing supply is. So each chain, for any chain which speaks IBC, any other chain which it's talking to using ICS-20 has a balance, basically. And when I send tokens from my chain from Enoma, say, to the Cosmos Hub, I track that. And if the Cosmos Hub ever tries to send back more, I will reject the transaction. That's all well and good and works just fine and provides fault isolation in the sense that no other users of that token on my chain are subject to risks, only users who send it over to this particular chain. So the inflation is prevented by tracking supply. But as soon as you shield the transfers, then suddenly that information is gone because you're shielding the transfers. So what do? Then if you want to, it's also complex just sort of implementation wise, because you're trying to track this kind of aggregate statistic across transactions, namely the total value in or out, which is sort of like design wise pretty incompatible with the way like the sapling circuit works, because it's not tracking any kind of state, which is cross user dependent. So if you want to do like addition in private, then you need homomorphic addition or something, and you need to connect that to the circuit. And that will get very complex very quickly. Although, and even in principle, you can't track it exactly, because if you track it exactly, then like just by looking at the difference, if the value is public, by the difference in the amount, you would know what the value of like the transfer was by subtraction. So you need to, there's like some balance maybe of tracking the supply, so you can provide fault isolation, but tracking it like within some error margin. And then you have like privacy, except there's this sort of bound on what the total value transferred in some unit of time was. And maybe that's sufficiently, maybe that's like a balance to be achieved. I'm not sure where.
So would we say that it's still a work in progress, or like, do you have the solution?
So this problem is not specific to Enoma at all. It's general to anyone who wants to do, this. I mean, it's general to the sort of ecosystem of IBC Connect change writ large, insofar as we all want to like share our privacy sets because the more the better, but we also want to isolate our faults because the fewer the better.
Makes sense. So what's so cool about these three presentations, by the way, is how they kind of targeted very different parts of the Cosmos stack. And I really like that. I want to kind of move on to Henry. You had sort of presented this, like, for anyone who's just seen this panel and didn't actually see the talks, was this idea of like private validation. I had this leftover question. You kind of have a completely new thinking about that in order to keep delegations private. But you talked about this cap, like it being like at the unbonding point, some sort of cap gain happening. But what was that based on? Like, would that be time spent or amount in? Because if it's amount in, wouldn't it reveal what you're trying to hide?
Yeah. So I guess there's sort of two parts to that question, if I'm understanding it correctly. The first part is like, how does the, like a reward amount on unbonding or undelegation work? And then the second part is, how do you avoid some kind of linkability between delegations and undelegations, right? So the way that the reward system works is that in every epoch, all of the bonded stake is inflated by a factor of 1 plus the reward rate relative to all of the unbonded stake. And then for each validator, some portion of that inflation is captured by the validator as a commission, and some portion accrues to the delegation holders. And the exchange rate is perfectly accounting for all of that cumulative inflation. Or it's actually not necessarily inflation. It depends on which sort of side of this you're picking as your reference asset, which I think is also pretty interesting. Like, one perspective you can have is either you have bonded stakeholders are being compensated for taking on some risk, right? That's corresponding to choosing the unbonded stake as the reference token. Or you could choose the bonded stake as the reference token. And from that perspective, people who don't bond and don't take on any risk are penalized for not doing so, right? So that's this kind of equivalence. But there is a problem with potential linkability, where if I see that there's some bonding amount and then there's some unbonding amount, and I know that there's like particular relations between those things, can I work through all the possible combinations of epochs and figure out whether there's like a known ratio and do a correlation? And the solution to that is that actually, because all of the consensus weights are only updated per epoch, you don't actually need to declare publicly how much you're bonding. You only need to have the kind of net flow into a particular validator's delegation pool be public. And so the solution is that when you do a bonding transaction, you would encrypt the bonded amount to all of the current validators. And then in the last block of that epoch, they aggregate all of the bonding transactions and then decrypt only the net flow. And so
Got it.
There's still maybe some correlation, like maybe you're the only person who bonded in that exact epoch to that validator. But that's sort of like this, there's some stuff you could do to mitigate that. Like maybe you get client software to like, bond in different chunks, or maybe people are bonding to a bunch of different validators, or, maybe you build the system and then it's successful and then it has users. And then, if you have a lot of users, then ideally you have a big enough anonymity set.
Fine.
Like if you make a privacy tool that has no users, then there's
Makes
no
sense.
design that you can do that will fix that.
All right, I'm gonna move on to Dave's project. I know Sunny, you and Sunny have been switching places, but given that I'm going to ask a question about the presentation, then maybe it does make sense that you're here. And it's actually generally about the project. Do you feel like the work that you're doing right now is really specific to Cosmos, or could that actually be like also used for Ethereum and ERC20s?
Yeah,
Because,
so I think So I think Cosmos encryption is a great solution for mempool privacy for anywhere where you can have this sort of BFT setting. So Cosmos is kind of natural because there's tendermint. Base layer ETH and ETH2 don't actually have this very naturally. ETH2 has this design goal where if there's only one validator that's live, the chain should keep proceeding.
Okay.
So you don't actually have a threshold that you can like rely on. So what you could do is like you could maybe have threshold encryption where the threshold can be delayed. But this then reintroduces some like MEV opportunity. But for rollups,
Cool.
like you can do a multi-validator rollup situation, and this works great. Like can be directly applied there.
Nice. All right, now I want to.
You get safety in that. Hold on. You get safety in that context of a roll up, but you don't get the roll up's liveness guarantees because you have this is like a pedantic thing, but like, and this is an interesting, I think, question for the Ethereum community is going to be is like, the argument for like roll ups is you have both the safety and liveness properties of the underlying chain. For most rollups, and if you were to add something like threshold decryption, you could get safety properties from, let's say, Tendermint, but you wouldn't have the liveness properties of the underlying chain. Like the rollup could get stuck.
It doesn't depend on your model of like, do you have transactions be posted on L1 first, or do you have them be given to a sequencer and then batch updated on the L1? Because you could have this, sequencer network still come to consensus and just keep doing batch updates to L1.
Anyways.
So I think it still works out there. You just block on the liveness of L1 eventually, like after you've proceeded by some amount.
So I want to now kind of take it more into a general context. And this is a bit back to you, Zaki. Do you think that there is a business case for privacy on Cosmos? Like, I want to bring it back to that. Like, we've now seen these 3 really fascinating examples of using privacy in these different ways. So I don't know if I fully business. So that's what I want to throw to you.
I guess the biggest core observation is without privacy, value is being extracted from users, right? Like that's the core observation is like behind all of these protocols. It's like when you are transacting in public on Ethereum, you're like value is being transferred from you to another party. Usually that party is miners, like front running bots, that kind of stuff, right? And like that value capture is, and so, the proof of stake world is like, maybe we start socializing among the validator set more of that value capture. And it's like game theoretically a fairer playing field for that value capture to be distributed more evenly. And like you see that in things like the gravity DEX design, where you have these like, batches of transactions that are computed that sort of, so like that's the proof of stake world. But in order to actually get to the point where the users of the system keep all the value, you actually have to get to the privacy world. And that's the clearest business case for privacy, right? The clearest business case for privacy is users keep more of the value.
I mean, Henry, you kind of mentioned that as well. This like trying to, I mean, I think we all actually thought about this idea of like making sure that these incentives are aligned. Do you think that there's a certain place that the alignment should happen first? This question goes to anyone here. Like, does it need to start from the top? Should it be in that like consensus level, or can it be lower down?
Well, I guess one thing about privacy that is important to understand is this idea of kind of like multiplicative decreases in anonymity sets. So if you think of privacy as being about really, control of information disclosure, then it's more clear why that's important, because when people are transacting, ideally they would like to disclose or control what they're disclosing. But each sort of piece of information that is disclosed ends up having a kind of multiplicative impact on the amount of privacy that they're going to have overall, right? If you leak one bit over here and you leak another bit over here and a third bit over there, then instead of, being 3 times smaller, you're actually 2 to the 3 times smaller, right? You're 8 times smaller. And so the kind of fundamental like incentive or benefit to putting privacy into base layers as deep as possible is that it gives you this kind of substrate that you can then build other things on top of. And if you have that substrate, then a lot of things become a lot easier. So for example, in the case of trying to have privacy preserving swaps, right? There's this paper that came out recently about how, privacy and constant function market makers, where effectively all of the information in the trades and the prices is also in the function. And so you can't really hide one without hiding the other.
Mm-hmm.
And the conclusion of that paper is like, oh, well, this means that privacy for these CFMMs is impossible. But in that model, right?
Not exactly that.
Model,
there's mitigations that were proposed, but yeah, like I know what you mean. It makes it hard. Yeah. Right.
If you're starting from like, oh, well, we can precisely identify that this transaction was made by this person, and the amount is tried to be protected, but then we can recover it from this other information. Well, if you had built that on top of this kind of like private foundation, where all of these transactions are kind of recycling the same anonymity set and breaking linkability, then it's much easier to solve. So if the deeper that you build the privacy into the system, the easier it is to have more private features on top of that foundation.
That makes sense. There's a question here. Jonathan asked, can you talk about programmability with privacy? And I guess that could actually go to anyone here. Jonathan, oh, you go ahead.
Oh, sure. I guess this is asking kind of about maybe the Uniswap example Henry's talking about, where you have this this contract on chain, and you want to have private data go into it, and get some private output. You have this fundamental problem that you need the state update to be public. And so this is the problem with Uniswap. Like when I do a trade against Uniswap, I need everyone needs to know what's the remaining reserves on both sides. So you can infer then, you can back infer, what was the transaction data, or for Uniswap in particular. Some things you could imagine it's many to one, so you can infer, given the public state update, it's one of these transaction types. But you can still get privacy here, where privacy then means maybe two different things depending on context. One is that like who did the action is private. So this would be like a Zcash style fee payer system on if you don't have privacy built in very deeply, you have to do some other trade-offs like Henry was mentioning, that you have to go, like one thing is like you do the Aztec batch transaction thing, which then grows complex, it gives you less privacy guarantees because it's not built into the L1. And the second thing you can do, which is like you could hope to hide your transaction until it's finalized, which is often what people may want for like trading. And it's MEV resistant stuff, like mempool privacy things.
Oh, Sunny, I think I can add Sunny in now. I hope I can. I think Sunny just joined. Yes. Okay, good. Hey, did you want to jump in and say something on this?
Nope, Dave covered it perfectly.
Oh, okay, great. I wondered, like, are there parts of, I mean, I don't know if it's parts of IBC, parts of certain parts of any stack that are missing that make it, I mean, we talked about the Rust versus Go, but like, is there anything else that we could even maybe encourage the audience or the community to start working on that maybe a lot of people feel is missing? Yes. Oh, I think Zaki just had to bounce.
Okay. Well, I guess
okay.
One question I've had in my mind, I've been one of these answers to is, are there approaches to cross-chain privacy where like two different chains can share the same anonymity set, but efficiently? And so I don't think no one's working on this to my knowledge. And the only idea we've seen a bit discussed is you can hope that you have both chains share a nullifier set if you're thinking Zcash style, where Zcash is nullifiers, and then you kind of do some, you make tokens encode what chain they can be spent on, and you have all nullifiers go under some like cross-chain agreement protocol. But I don't know if there's other ideas. I think there's a huge design space open here that should be explored.
I mean, Henry, I know previously you were working on sort of like a peg zone, right? Like this idea of having one zone dedicated to that. Would that, like, does that, I know it doesn't solve the problem that you just highlighted, but would that also be like, if that existed, does that open up something? Is that something that people should aspire to?
I don't think that would really solve the problem, because in that model, you still had, the actual transfers are still public. I think to the point that Chris made earlier about this tension between kind of like fault attribution and privacy, that seems pretty fundamental to me. If you want to have if you don't want to, reveal specific amounts that are moving between chains, then you can no longer know about specific amounts that are moving between chains. And that's the problem. So, you might be able to build something, for instance, that kind of like interpolated between those two extremes. So you could potentially build some kind of a batch value transfer where, people would kind of queue value to be moved over IBC, and then the entire batch would be moved kind of all at once. And then you sacrifice attribution within that batch for privacy, and the kind of length and size of the batch has user implications for how long they have to wait for finality, or like, because if I'm a user and I want to move funds between two zones, I kind of don't want to have like ACH on the blockchain where I have to like wait 3 days for it to settle. Like that is kind of sad. And I think people are used to the idea that, especially in a system like Cosmos where you have like finality, I think people are used to the idea, I make a transaction, 10 seconds later, I'm sure that it's been committed to the chain.
Yeah.
I think there's, sorry, you go, Chris.
Go ahead.
All right, well, Dave, you can come out.
Oh, okay.
I was excited to hear what you have to say, but okay. I was just going to mention that I think one part of the trade-off, or the like tension, which is particularly tricky, is that the IBC security model is dependent on this concept of like value flow in time. So if you think about some kind of potential attempt at misbehavior or attempt at Byzantine subversion and double spending across an IBC channel, that's happening like in time. And IBC itself is composed of several layers of defense. So the initial layer of defense is just like, if you have less than a third Byzantine, you have all of the guarantees of the light client algorithm. If the light client algorithm is secure, your chain doesn't fork and you're all good. But even if that fails, IBC has secondary layers of defense. And those secondary layers of defense work by detecting misbehavior. So cases where faults are attributable, even though it's like more than a third potentially that is faulted, but attributable from the perspective of another chain, because the other chain like has their own consensus. So that they haven't lost their ability to come to agreement on what happened. So they can still see that, oh, a fault happened, like I should start treating this IBC connection accordingly. And the way in which they learn about that fault, however, is dependent on processes which are happening in time, in time which is asynchronous across these chains. So it's dependent on the submission of misbehavior evidence about what the validators actually signed, which in this case was like wrong or a violation of the protocol somehow, to the other chains which are interested because they're running light clients and speaking IBC. And that evidence submission like happens is something that's a function of time, function of like when stuff gets gossiped over the network and who could do things so fast. And because of that, in order to contain the faults, you want to contain the flow of time, the flow of value over time, because you want, this other chain, I want to know that, oh, like if some fault happens, it's attributable, and some information is like some missing proofs consisting of signatures of the validators or whatever they did which was wrong gets necessarily exists somewhere, and I want to have time to learn about it, but before too much value is floated on my chain. But then that also has tension potentially with certain kinds of privacy schemes based on batching, insofar as batching might involve like sending one IBC packet, which does the whole batch at once. And that whole batch at once could then be timed by the validator set, which is attempting to misbehave so that they could like move a lot of value at once. So it's a really tricky tension because, go ahead.
I think something interesting though in this
tension
is that, we can use state validity proofs for the flow rate. Like you could snark properties you want guaranteed about flow rates between chains. Like, and then as a chain is connecting to you, I can then get guarantees that I can then get my flow rate guarantees, even with privacy like being added in here.
But how do you do the like addition? I mean, you want to keep the state, right, of the flow.
Okay, maybe yeah, like I could have this. I have an invariant that you did not mint more of these tokens that were IBC'd, like an invariant total sum, right? Like all these IBC lock tokens weren't inflated.
Maybe, but then it sounds to me like you need that kind of proof, like over the whole state machine. Yes. Okay.
I think you just need it for the state root, for the IBC state roots, and anything that goes in and out of the IBC state root, not the rest of the.
Yes, if you logically isolate the part of the state machine responsible for executing IBC, and then have state validity proofs over that, that helps, yes, but I still don't see. So if shielded transfers are happening there, how do you still need to like compose somehow the amounts of the shielded transfers and add them together without revealing what they are.
Yeah, I guess we would need some sort of sum invariant that like the sum of transactions in and out. Like,
I mean, the other problem is that these are not like necessarily, I mean, this is like maybe a more approachable problem, but the, say, trusted setups used for zero knowledge proof schemes, or even the zero knowledge proof schemes themselves, are also like not necessarily something that's going to be agreed upon by different chains in the Cosmos ecosystem in terms of what counts as secure.
Yeah. Is there a preferred ZK construction so far in Cosmos? Is it sort of deferring to snarks, or is there any like particular circuit that people are using more? Do you know?
I mean, in my opinion, like the best documented and specified zero knowledge circuit in the world is still ECC sapling, and that's what we've built on top of for the MASP.
Okay.
So in terms of shielded, and I think that's, as I understand, Penumbra is like also basically an extension and lots of additions to that design.
Yeah.
That solves a very particular problem. It doesn't solve other problems. So like to solve other problems, you need other circuits. In terms of zero knowledge proof scheme, I don't know if there's one which is specific to Cosmos. Halo 2 and like Plonk and PLOOKUP are kind of sort of converging towards the same point in the design space, which is indicative, at least to me, that that's like a natural direction. It probably will result in some kind of common standard, but it hasn't exactly happened yet.
Got it. Somebody asked a question here, asking us to kind of throw back to this Go versus Rust debate in ZK land and Cosmos, and Zaki's not on here now, but he's the one who brought it up. Maybe you all have opinions or thoughts on that, given that you're working with these.
I guess my thoughts are that I see no issue with just using Rust for compiling and then doing like static linking or dynamic linking to get your nice performance for Rust cryptography and Go. I think re-implementing is like a not great strategy, though there is now a great like Golang like snark library for some of the popular schemes from Consensus called Gervi.
Yeah, I heard about that. Yeah,
but I still have a preference for like find Rust, just because of standardization.
Do you then want to see Cosmos head like move more towards Rust generally? Like, would it be nicer if you didn't have to make that connection point, or is it just so irrelevant it doesn't matter?
Well, maybe I'm prematurely speaking because I have not written the bindings ever myself, but I feel like, we can automate a lot of the binding difficulties. Henry probably knows a lot more here than I do.
I don't really know anything specific to the Cosmos parts, or actually really about the kind of mechanics of doing complex bindings. I do know that like most of the people who I know personally who have attempted to do some kind of Go related FFI that wasn't CGO have not had a super fun time of it. Go, as like a design decision that they made, it's very like special. And like, it has this cool mechanic for doing like stack handling and everything. And that provides benefits for Go. But it means that it's like less straightforward to do kind of like in-process interop.
Got it.
So I'm happy to go out on a limb here and say that I think we should just move towards Rust. I think in most aspects, Rust is a better language for building blockchains. It loses to Go a little bit in terms of usability and familiarity and like ease of working across a very large code base, especially if people are using a lot of macros or sort of non-idiomatic Rust, but it wins a lot in performance, in like degree of error checking and type checking, which the compiler can provide. Of course, integration into cryptography libraries and also concurrency, I think.
So I want to finish what you were about to say. No, I was about to change. So yeah, sorry.
There's also Informal Systems has, I think, a long-term strategy. Hopefully it hasn't changed. I don't want to misquote them, but to eventually work on Tendermint and Rust. There are already, of course, ABCI bindings, and we're slowly moving towards maybe there will be like two parallel ecosystems. Maybe there will be bindings in between them, and people can mix and match components. But I do think it's worthwhile to pursue long-term Rust.
Go ahead.
One thing that I would just like finally note is the kind of benefit of having a more powerful type system that lets you express these more complex invariants, right? That's the obvious benefit of that is, okay, now we have this system that we're trying to design and it has all this complex behavior and we can encode it all into the type system and have the compiler check it for it. Great, wonderful. But the kind of under discussed kind of downside risk of that is that doing that kind of encoding state invariance into the type system is like actually a kind of non-trivial skill that people need to learn. And I think that's part of the kind of like learning curve of like effectively using Rust. And if you like don't do it well, then you can end up with this kind of like cemented spaghetti code that's completely impossible to change because you've like encoded all the wrong invariants into your code base. So that I think is a challenge.
I want to, since Sunny's on here and we haven't heard from him yet, I hope you don't mind if I want to ask you a little bit about, and I don't know if you're thinking a lot about this, but where you would maybe like to see privacy in Cosmos. If you've been, I know you and Dave, you've been exploring a few different spots of using zero knowledge proofs. Right now you're doing this presentation was on the threshold cryptography, but I want to hear from you what maybe else is on the horizon and what you'd love to see.
Yeah, so obviously there's the threshold. I mean, I try to think of it from a very practical standpoint of like, what's the highest value use case? And like, I'm coming from like we're building a product called Osmosis, and which is a DEX platform for Cosmos. And, I'm approaching from a very practical standpoint of like, what is the features that people want to see? And so from talking to people, the one that people wanted the most was the front running prevention, which is what we started with. The next piece that we want is, I think Dave mentioned it earlier, but this like very practical idea of like, hey, like, getting everything working in a fully private system is not like really what, or it's a nice end goal, but it's probably not the like way to get there, right? And like you actually do want a lot of things that are public. Like, it turns out people actually don't like dark pools as much. Like people want to see the order book and or they want to see the AMM pools and things like this. And so having systems where it allows people to like, and so, you know, the simple solution that we were like, hey, the easy V1 for this is just having a shielded pool, which assets can like come in and out of, and try to, you know, it's not going to give you the like full level of privacy. There's all these sorts of like things you could do to like, you know, reverse engineer, like figuring out what's happening. But like, you know, if you're making it harder at least, and like giving the tools that allows people to like make it as easy as possible for people to like shield as much as they can. I think that's like at least the first like pretty good step. And yeah, I think that's what people care about most. Like I've talked to a lot of like traders, and they're like one of the like people who like traditionally trade on or like market makers on like centralized exchanges. One of the reasons that they actually don't want to market make on like decentralized exchanges and stuff is that they're like, we're literally leaking our trading strategies. Like, and so they're not, their goal is not to like compete against like state level actors here, right? They're just trying to like hide against like other traders from like copying them. And really what they care about is like hiding in on the scale of like a couple minutes, because they just don't want people copying their trades in the next couple minutes. And so this is kind of like the more practical, like stance that we're trying to take.
It's so interesting because I'm hearing that not only here but in a lot of ecosystems. Is this like there's two privacies? I mean, this is fairly obvious, but there's the privacy for the individual or the business from their competition or just like random people, and then there's privacy from the analytics and the governments and all of that, and that's different. And I know that like if you're talking about a trading context, then I think it's mostly just like to provide, like to be able to keep your strategies to be your own, and not have to share those. But I wonder, like, it's so funny because I feel like there are also different camps of folks who like would worry that if you only focus on the light privacy, that deeper like lack of privacy will come bite you in the ass so much worse. Like the state actor. Oh, and we have one on the call, but two at least. But it is interesting to see how these, like when we talk about incentives, like there also are no incentives right now for private style, like DEXs who want privacy to necessarily offer that full level of privacy. And the incentive is not built for that. Henry, do you put your hand up as a counter? So what is your thinking?
I did a thumbs up. So I agree. I would self-describe as that like person who thinks that the like trying to draw this distinction is going to come around and bite everyone in the ass in 10 years. Like I think that one of the trends that you can see in like technology and surveillance technology in particular is that over time, the cost of having some capability comes down. So if you think about the way that online advertising works, it's like actually structurally quite similar to the kind of like, you know, program that you would need to monitor everyone's web browsing activity. But it's just done by all these random like companies. And there's people like Chainalysis, right? That's not like people often in the community, people sort of like lump in Chainalysis with like the feds, but Chainalysis is just a company, right? They obviously do a lot of contracting with like state actors or spy agencies or whatever, but there's no fundamental reason to think that there is a kind of hard line that will last into the future. There's kind of an evolving landscape of, on the one hand, you have privacy capabilities, and there's a kind of marginal cost to effort, or you know, how much privacy you're getting for how much effort you're taking to use this tool. And then on the other side, you have this kind of spectrum of surveillance and monitoring technologies. And that landscape is not fixed. It changes over time, but the terrain that is being contested there is fixed. So you only actually get like movement in the direction of de-anonymization. You can't retroactively like boost your privacy.
Anonymize. But that's what I'm wondering about, like specific to Cosmos, like bringing it back to this particular ecosystem. Like, do we know what the sentiment of the Cosmos ecosystem is towards privacy? Like, is this an ecosystem that is thinking like that, or is it an ecosystem that is like wants this to actually be very free flowing, very transparent in the end?
So I don't know about now, but at least I remember in Tendermint office, we had heavy debates about this. You might remember, Chris and Sunny, where some people really wanted the hub to never have privacy, and a lot of us wanted to have privacy on the hub. I don't know. I was not very much of the let's get lots of it, but
let's get lots of it.
Yeah.
There certainly are, I mean, in applying privacy to particular aspects of blockchains, there are dangers that don't surface when applying it to other aspects. So I think private proof of stake is interesting and has compelling advantages, and also has like potential dangers insofar as it makes it much harder as a user to ascertain what the security of the system you're using actually is. And maybe there are ways to mitigate that, and maybe a good counter argument to what I just said is that users can't ascertain what the security of the system they're actually using is anyways, because validators' identities are difficult to discern. And potentially like all we can really do is incentive design, and it makes more sense to focus on things like correlated slashing than worrying about whether the validator's identities are public or not. I'm sympathetic to that argument, but it's like not clear to me. It's still like conceptually rather hazy as to like what that trade-off space looks like.
Another one is voting, right? Like governance voting. Like I think that was like one of the topics of like, for the Cosmos Hub, which is like, do we want governance voting to be private? And I think I was on the stance where like probably not. I mean, I want reputational harm done for like malicious voting.
The staking driven design that private staking designs I've seen, like with delegation, I guess not I've seen, Henry's talk, like introduces derivative tokens, which is actually a huge change to the underlying staking model security. You've removed this unbonding period stuff. Like
there's I didn't mention it in the talk, but there is an unbonding queue.
Oh, never mind. This is perfect.
Yeah.
No, I take that back then.
You don't get like instant settlement on that. Sorry, I should have been more clear.
I mean,
Tony
another
just
example.
Tony just actually added to this a little bit for the voting idea. Give validators the ability to prove how they voted, but don't force them to. That would be cool, is the comment.
Well, it kind of seems like there's a potential distinction that you might want to do between validator votes and delegator votes. So if the setup is that validators are voting on behalf of their delegators as a kind of a default vote, I think it does, and the validators are the ones participating in consensus. I think it does kind of make sense to say like validators have accountability and delegators have privacy. But maybe that's just easy to do because sorry.
Oh, I was saying, and we should extend that to like liquid democracy as well. Like, you have not just validators can delegate to, but anyone can be delegated to. Whoever is like your delegate should be public, but all the constituents can override privately, with the non-step being constituents to that entity.
I thought a
like
little
not
bit
leaking your address.
Trying to build some kind of like liquid democracy style delegation of stakeholder voting. But the thing that I got stuck on is ideally you would want the voting to be split out into a kind of separate capability. So for people who aren't like super familiar with Sapling, there's this cool, like crazy hierarchy of all these different keys that are involved. There's not just one key, and each key corresponds to kind of a different capability of something you can do to that node, whether that's like spend it or view it or whatever. So maybe you could try to do something like having like a governance subkey that would allow you to only do voting. But if the voting mechanism is kind of piggybacking on spending notes, you have a challenge where the person who you delegate authority to like do the voting to, you might like not create a new note for you to keep your balance, right? So you'd have to have some kind of like constraining that they like did the voting correctly, and that's tricky. But I think that would be really cool, and we could just build it, you know, like well, like one of the problems with trying to do like a liquid democracy style system is that if the idea is that you're going to implement this kind of like, oh, delegated voting for democratic decision making, and we're going to hook that into kind of like an existing democratic institution that we have, then you have to like, you know, get everybody on board first before you can even like build and test the system. And I think that kind of ties into one of the things that's like so exciting about the blockchain space, is that you have people basically speed running like every single possible coordination mechanism design that you could ever imagine. Like, sure, let's just build it, see what happens.
And
maybe
then they
it'll
blow
explode,
up.
maybe it'll
Yeah.
work. Yeah.
It's kind of cool. All right, we have 3 minutes left. I don't know if there's any other questions from the audience, from the folks there. John gave an example of this delegated context and privacy and a link there. But yeah, if anyone has any other questions, or if any of you want to say anything else about this topic of privacy, Cosmos.
I mean, I think one thing to be like that's interesting is like, I think one of the major projects right now in the Cosmos ecosystem is the secret network, and I think they take like a very interesting approach where like they kind of, you know, forego all this like cryptographic and like stuff, and it's like, you know what, let's just like use like the simplest possible way to get this done, and just like use an SGX. And like, I think in Dave's talk we talked about like, well, we're not super big fans of SGX, but at the same time it's like, for depending on your use case, I think it is actually quite a pretty I think it solves some people's use cases. And in fact, I think like Secret Network is actually like underselling themselves. I think like the interesting side of them is not the privacy, but rather because like, well, like I think the privacy isn't the interesting part. I think it's really, it's like, hey, it's a replacement to an MPC. Anything you need MPC for is like, hey, you can just use this like secret network thing. Like the SGX is like such a hack, but it's like, if you're okay with the Intel safety model, like trust in Intel, the other problem with SGX is that there's an availability problem to it, right? Like I can just shut off my server that's running my Intel SGX, but Secret Network kind of solves the availability problem for SGXs by creating a distributed SGX, which is, I think that's a useful thing to have.
Well, it's not useful for the goal of privacy for private state. Like Henry's point earlier, like for private state, this is maybe one of the worst like things you can do if you want long-term security. Since or sorry, maybe I'm overselling what Henry's point was, but 10 years from now,
it depends on what your use case is, right? Like I can totally see there being some users who like find value in the level of privacy that Secret offers that like I think no other production system offers at the moment. I think Secret Network currently provides capabilities that no other production level system provides. Even if it's not the best level of privacy you're going to get, it's better than not having that capability at all.
Bringing this up, by the way, just made the chat blow up with lots of opinions. So actually, this might be a great moment to sort of thank all of you for coming on and coming to this event. I'm saying coming on like I'm still doing a podcast. Thank you for coming to this event and for sharing all of this. We're actually going to break out now into a setup where we can go to the sessions and create our own sessions. So we're going to just create another one of these. I'm going to create one, but I would love it if you will also, all of you here, create new sessions so that people can actually engage and have this conversation continue. But big thank you to everybody. This was a very fascinating event. I feel like I'm coming away with a better sense of what's kind of possible, what the issues are. And we're going to definitely be creating a report or some sort of blog post about what we've learned today. And we're also going to have a form that we're going to share with a few people to try to get some ideas around, what other people are thinking. So yeah, I'm going to shut this down. I think if you all want to bounce out of here, I think it shuts it down and we'll head over to sessions. Thanks, everyone.
Thank you.
I,
Ciao, ciao.
mm.